All right, next on the list for the Enterobacteriaceae is Salmonella. Now, I do have a little microbe friend for Salmonella, so I'm going to use him to talk to you. He's motile. Remember, salmon swim upstream. And how does he swim? He has flagella, okay? So he has flagella, he's motile, and remember, he is an H2S producer. Now, there are thousands of different serotypes of Salmonella, and they're serotype typically based on the O antigen. And the species have very complicated names because they went in, and I know you love when they do this, me too, and they go and change the name. I don't think it's caught on because most of the literature I still read refers to the old nomenclature. But I'm going to give you both. So what they've done is they've taken the entire genus and everything goes Salmonella enterica, and then the old species name became a subspecies. So for example, you had Salmonella enterica subspecies typhi for typhoid fever, or Salmonella enterica subspecies typhimurium for gastroenteritis. Still, probably on the USMLE, I'm almost positive you're going to see it, Salmonella enteritidis, Salmonella typhi. But in case it's caught up, you want to be able just to be aware that the nomenclature is changed a little bit. And this lists all of the species, subspecies, showing you that they're all Salmonella enterica, and then the old species name simply just became the subspecies name. Now, what are the distinguishing features? Again, it's an H2S producer. It is motile. Remember, he can swim. And it's acid sensitive. So you need a pretty good whopping dose of organisms to cause disease. And like we talked about, for Shigella and cholera, for typhi specifically, and this is different than for typhimurium and some of the other species, but for typhi, humans are the only reservoir. There are no animal reservoirs for typhi. Now, transmission is from people typically that are chronically infected, and they set up a chronic infection in the gallbladder. That is a money question. I like to call that a money question because with a case of typhoid fever, they're going to like to ask you where the chronic infection is set up in that patient. And the gallbladder is the money answer there. Now, what else aids in transmission? If you're on some of those proton pump inhibitors, Nexium and Prilosec, and you're lowering the acidity of your stomach, that's going to make it much easier to acquire an infection with Salmonella. Now, when I talk about the pathogenesis, I'm also going to talk about the disease for typhi because they really kind of go hand in hand. So in this case, remember we're talking about typhoid fever, which is caused by Salmonella typhi. Now, if they're asking you a diagnosis question, you know in the distractor list you're going to see typhi, and you'll certainly see typhimurium and probably paratyphi. So you have to know that we're talking specifically about typhi. Now, you ingest the organism. So this is transmitted fecal-oral from contamination from a chronic carrier who has the infection set up in the gallbladder. So it's a fecal-oral contamination. And the best example is the Typhoid Mary. And in Typhoid Mary, she was a cook for wealthy families back in Manhattan, actually. And she had a chronic Salmonella typhi infection. And so as she cooked for the family, this was before we knew much about hand washing and sterility, she would cook for these families. There would be fecal-oral routes of transmission, and the people that she cooked for started getting ill. And it just so happened that most of the families that she cooked for, people were getting ill. And even before they knew much about diseases and bacteria, they realized that it was probably coming from her. Okay? So she was spreading it. They were ingesting the organism. And one thing I want to point out here is after ingestion, one of the first symptoms you're going to see from Salmonella typhi is actually constipation. We haven't talked much about things that stop you up, mostly things that cause this voluminous, horrific diarrhea. So if you're reading in a vignette on step 1 about constipation and fever, maybe alternating even with diarrhea, you got to start thinking about typhi, especially with a history of travel to an endemic area. Okay, South America, for example. So, constipation is common in the beginning of the disease. Now, what happens with Salmonella is a little bit different than what we talked about with Shigella. Salmonella will get taken up by the M cell and do not mind crossing the M cell and getting into that little lymphoid pocket of cells that are sitting right beneath the M cell. So it gets taken up by a macrophage on the opposite side there of the M cell and uses the macrophage really as a vehicle to travel through the blood and seed some of the other organs. So once they get to the other side of the M cell, they're going to get into the blood, and this is where you get a primary septicemia. So after about a week of the infection, you can find the organisms in the blood of the majority of patients, and about 25% of the patients have these characteristic rose-colored spots on the trunk and abdomen. So they're just a little tiny pinpoint macular rash on the trunk and abdomen. You can't always bank on them giving you that information because only a quarter of the patients get that. If they give it to you, that's great. If they don't give it to you, you can't exclude typhi because they're not mentioning the rose-colored spots. Now, once it gets into the blood, what's going to happen? You're going to start seeding other organs. Here's where the liver gets seeded, the spleen gets seeded, and now we're able to actually set up that chronic part of the infection in the gallbladder. Now, at this point, when we're really now additionally releasing organisms into the blood, we get a secondary septicemia, we get fever, and some of those associated signs of having bacteria in our bloodstream. Now, again, talking about virulence here, typhi does survive intracellularly in the macrophage. How does it do that? It has decreased fusion of the phagosome with the lysosome. And remember, that's when a lot of the killing really happens. So it's able to escape. It can defend itself against some of the mechanisms, even some of the oxygen-dependent killing mechanisms. So it's fairly tough once it gets inside the macrophage. Now, we talked about it getting into the liver, it can get into the gallbladder, and now you're really just constantly shedding organisms in the stool. And here's where really you're a good source for spreading this disease. The symptoms by the 3rd week also, though, include fever, headache, and again, constipation, more common than diarrhea. Although I don't want you to think this doesn't cause diarrhea. It can. If you're reading a step 1 vignette and you have somebody with fever, they have fever and constipation, then maybe a little bit later they have fever and diarrhea, goes back to constipation, you want to start thinking about typhi. Now, what are some of the complications? Because the organism is chronic, it can seed and target other organ systems. You can get necrosis of the Peyer's patches. You can get thrombophlebitis, for example, and you can see the list of other complications of Salmonella typhi. So it can cause death due to some of the complications, but in the case of typhoid Mary that I was talking about earlier, I believe there was only one person that actually died from her spreading the disease, at least in the primary setting where she was cooking for the families. I believe there was only one family member that died, but a lot of them became sick. Now, diagnosis, you're going to isolate the organism. You can do it from the blood. You could do it from the urine. And you can actually biopsy those rose-colored spots because you can find the organisms within that rash that, remember, was only found in 25% of the patients. Of course, you do have to treat typhoid fever, and the drug of choice here are the fluoroquinolones, or you can use, again, a higher generation cephalosporin. Typhoid fever, is a disease of poor sanitation, so that's always going to help prevent the spread. So you're not going to tend to find typhi in developed countries, but in developing countries is where you're probably going to find cases and epidemics of typhoid fever. There are actually 3 vaccines for Salmonella typhi. They are usually administered to people who are traveling to an endemic area that can then receive the vaccine before they go to protect themselves. So there's 3 different types. There's an attenuated one, which means it's live. There's a heat-killed one that we no longer use in the United States. And then there's a polysaccharide capsular vaccine, like we mentioned for meningitis and we mentioned for streptococcus. So different types of vaccines. So probably they're not just going to ask you about the type of vaccine for Salmonella typhi, because it's really available just about any way you can make a vaccine. All right, now the other species of Salmonella, which are much more common in the U.S., are distinguishing features. Again, remember, this little guy is motile. He has flagella that can allow him to swim, and he can cause H2S production. So we have H2S positive and motility with Salmonella. Again, lots of different serotypes. You're really probably not going to have to worry about the serotypes of Salmonella that we're getting ready to talk about. But they are non-lactose fermenters. So again, they may give you the fact that it's grown on McConkey, but the colonies will not turn into that pink color. What's the reservoir? Now, this is why I love this guy so much. The reservoir is actually a chicken. And if you look at this guy, he may not just overtly look like a chicken to you, but because he's got the white body shape and the little red flagella here, they really kind of made him to look a little bit like a chicken. So that will help you remember that one of the reservoirs for Salmonella is chickens. The other one is actually turtles, believe it or not. So we actually stopped importing certain turtles that a lot of kids were getting for pets in the U.S. because they were associated with Salmonella infection. So the kids would be playing with their turtle, they'd be touching the turtle and then touching their mouth and coming down with Salmonella from the turtles. So transmission largely through poultry. So that's going to probably be the primary means, but you don't want to forget about the kind of strange pets that people have. Here I always think here about the crocodile hunter. You remember the crocodile hunter? He was awesome, okay? He had like nerves of steel, and he would be like, "Hey, Terry," you remember his annoying wife? He'd be like, "Hey, Terry, why don't I slap this croc around for a while, and then you jump on it, and we'll get it crated." He'd always piss the crocodile off before he wanted his wife to touch it. So I think there was some kind of theme there. But anyways, you see pictures of him, and he's always kissing what? Snakes, crocodiles, turtles. I have to imagine that he lived most of his life with a Salmonella infection of one sort. All right? So I always like to think of Steve Irwin because he was a pretty cool dude. All right. Virulence here. I'm going to make some cautionary statements to you about the virulence and pathogenesis for Salmonella. And here we're really talking about the species or the subspecies, Typhimurium and Enteritidis. What happens here is, again, you need a pretty large dose because they are sensitive to the acidity in the stomach. And the big thing you have to worry about here is that the organisms are invasive. So I know that Salmonella is one of the things you'll read in one board review book that it's bloody diarrhea. You'll read in another one that it's watery diarrhea. And so now you're on the fence. You don't know. The bottom line is it's invasive. It's always going to start off watery. Sometimes it turns to bloody. My daughter actually got a salmonella infection when she was 2 years old from eating, we think, contaminated chicken is what we traced it back to. And she developed fever, vomiting, and she had pretty bloody stools. Okay? So being in the daycare setting, the first thing I thought about was Shigella. And I took her to the pediatrician at the time. They didn't really want to treat her, but I was worried about the bloody diarrhea, as clearly any mother would be. So I cultured it myself, and lo and behold, I looked at the HE plate, and instead of seeing the, kind of clearish colonies on there, they were all black. And on hectoenteric agar, black colonies mean that you have a salmonella infection. So then we kind of traced it back, and we were actually having a little outbreak of it in the town that I live in. Now, so what do you need to know about that is sometimes it's watery. In kids, it can certainly be bloody. And I want you to really focus in on the mechanism here. There is no toxin with Salmonella. So one of the things that they might ask to make this kind of a clinically relevant scenario, they'll give you the scenario of somebody that maybe ate some contaminated chicken and they developed a fever, vomiting, and diarrhea. Maybe they won't mention watery or bloody at all. And they're going to want to know what the mechanism of causing the diarrhea is. And they're going to have toxins, and they're going to have inflammation. Because the organism is invasive, it causes an inflammatory response, which we'll talk more in detail about in the immunology, which is going to raise the levels of prostaglandins, raise the cyclic AMP, and function similar to a toxin. So you're actually getting the diarrhea in cases of Salmonella from the inflammatory response in the gut. All right? So remember that it's invasive. Don't get hung up on whether it's watery or bloody, but that you can have fever and how we're going to find this as far as diagnosis. Now, it's fairly common. It's number 2 after Campylobacter. Remember, Campylobacter is the most common bacterial gastroenteritis in the U.S., followed by Salmonella. So, we have nausea, vomiting, and occasionally bloody. So, we're all going to start off watery, and in certain cases, it can turn to bloody diarrhea because it is an invasive organism. Now, as far as sepsis, a couple of things I want you to think about here. Typically, species like Enteritis and Typhimurium will not cause sepsis, but there are other species that can cause sepsis. For example, Cholera suis, Paratyphi, and Dublin typically are associated with sepsis. Now, I want you to think about this because whenever we talk about Salmonella, we like to talk about osteomyelitis in sickle cell patients, all right? And usually it's like everybody knows. It's like, bam, osteomyelitis, sickle cell, Salmonella. Well, I've heard rumors. You've heard rumors? I've heard rumors too. That sometimes they don't just want to know that it's Salmonella species over staph. They want to know the specific species, okay? Now, in order to think about that, there's not one specific species necessarily that can do it, but you have to imagine if it's going to get to the bone, how's it going to get there? Probably going to get there hematogenously. So one of the organisms that can easily cause sepsis is more likely to cause osteomyelitis. So if you're faced with a ton of different species of Salmonella, you're going to want to go with one of the ones that you know gets into the blood. Not forgetting about Salmonella typhi, because typhi, as we already saw, gets through the blood as well. All right, so osteomyelitis in sickle cell patients, what species is it going to be? It's going to be a species that we know very easily gets into the blood. All right, so Cholera suis and Paratyphi and Dublin, and not forgetting about typhi. Now, diagnosis. Diagnosis is on something called HE, or Hectoin enteric agar. The agar itself is green, and the most crucial thing that HE agar is used for is to differentiate between Salmonella and Shigella. So when my daughter had this, and I cultured it, I used HE agar. And it's very easy then to differentiate because Salmonella is going to appear as those black colonies on HE, and Shigella is going to appear colorless on HE. Okay, so that's mostly what that's used for. Now, treatment again for gastroenteritis is pretty much self-limiting. So even when my daughter had this, we didn't treat her. And we tested her, though, to see how long she carried it. And she actually carried it for a few months. It took quite a long time to get it out of her system. Now, for severely invasive disease, where we're talking about sepsis, for example, in that case, you're very safe with a third-generation cephalosporin or fluoroquinolone. Again, a lot of the gastroenteritis is sanitation issues, so always proper handling of poultry, etc., helps decrease the spread and transmission of Salmonella. So, say goodbye to our little friend. Okay.